So a circle circumscribed about a triangle. That's when the circle is outside the triangle. So circumscribed means outside. And for it to really be circumscribed, the vertices of the triangle have to be on the circle. The next one, inscribed circle. The circle is inscribed in the triangle. And so inscribed means the circle is inside the triangle. For it to really be inscribed, the circle has to touch each side of the triangle. So like for this triangle right here, that circle is not inscribed in the triangle because the circle is not touching all three sides of the triangle. Okay? Okay, so those are just words that we need as background for what we're doing today and tomorrow. Okay, so for today, yes, the triangle can be circumscribed about the circle. That would mean the triangle's outside the circle. So like for this one right here, you can't see what I'm pointing to. Okay, for this one right here, the circle is inscribed in the triangle, and the triangle is circumscribed about the circle. So as long as you know that circumscribed means outside and inscribed means inside, then you'll be good to go. So today we're doing something really different, something kind of weird. We're just setting the stage for your points of concurrency assessment. So we're going to spend a whole day practicing folding patty paper. The whole day practicing folding. That's what we're doing today. We're going to fold. Okay? So you need the patty paper that I sent over a long time ago. And I think everyone needs 2 pieces of patty paper for today. You'll need more tomorrow, but you need 2 sheets of patty paper today. So go get those if you do not already have those. Okay. So, points of concurrency. What is a point of concurrency? A point of concurrency is just when 3 or more lines intersect at one point. 3 or more lines intersect at one common point. So my first picture, those pink lines are not concurrent. Yes, 3 lines are intersecting, but they're not intersecting at one common point. Same with my second picture. Those are not concurrent. They are not all coming together at one point. The last one, those are concurrent because all 3 of those lines intersect at one single point. It's like they're rendezvousing. They're meeting up at one point. Seems easy enough, yes. Didn't we do this? Yeah, I asked you a question about this a long time ago on a worksheet, but we're going to focus way more on it today. Okay. So what I need you to do is make sure you have a pencil, 2 sheets of patty paper, and a ruler. So make sure you have each one of those. Using your ruler, or really any straight edge, if you don't have a ruler, you just need a straight edge. Using a straight edge, on one piece of patty paper, draw an acute triangle and label it ABC. And on the other piece of patty paper, draw an obtuse triangle and label it DEF. Make yours look pretty similar to mine. Like put your A in the same spot, put your B in the same spot, so on and so forth. I'll give you a few minutes to do that. So you have one piece of patty paper that says acute, and your triangle is labeled A, B, C, and one patty paper that has an obtuse triangle labeled DEF, where E is the obtuse angle. So what we're going to do is we're going to work with our 2 triangles, and we're going to try to figure out how to construct, kind of, all 4 of the special segments. Remember them? Median, altitude, angle bisector, perpendicular bisector. So we're going to use our acute triangle to find 2 of them, and then our obtuse triangle to find 2 others. And then for your assessment, you're going to be doing this all on your own. So that's why we're talking today about how would you find the median? How would you find the angle bisector? Okay? So we're going to start with tomorrow, Eric. Can't we use normal paper? No, first of all, you want it to be smaller. Second of all, you want to be able to see through it. You can't always see through normal paper. Okay, so we're going to make an angle bisector from angle A. How would we do that? We can't use measurement tools. We're not allowed to use rulers. We're not allowed to use protractors. We're only allowed to use this sheet of patty paper. How could we find the angle bisector of A? We're not using a compass, a protractor, or a ruler. No measurement tools. Fold the paper. Very good. How would you fold it? Would I just like do this? Okay, folded it. How would I bisect angle A? Fold it so they meet, make the lines line up. Fold BC in half. Okay, we're getting closer. You need to fold your triangle, ACAB. You're cutting A in half. So you're kind of pinching at A, and you want CA to be perfectly, it's not the easiest thing you've ever done. But this, Lars, is why it has to be see-through. It needs to go right through the middle of A. C is not going to land perfectly on B. We're not finding the median. Will it look like an altitude? Only if your triangle is isosceles or equilateral, which I hope it's not. I hope it's just a scalene acute triangle. So when you feel like AC is perfectly on BA, then make a crease, make a fold, and you should have an angle bisector, not an altitude, not a median. It should be an angle bisector. So go ahead and draw darker on that crease, draw darker, and we're going to add markings to our picture. So I'm going to go over that crease with my ruler. I'm going to make it darker. And then on my patty paper, I'm going to add arcs. So I know that that really was an angle bisector. I just cut angle A in half. So arc, arc. They should be, you should have just made two congruent angles at angle A. It shouldn't be a median and it shouldn't be an altitude unless you drew an equilateral triangle. Okay, so Johan, now you know. You bisected the wrong one, so now you know for tomorrow. That's why we're practicing today, okay? Okay, so moving on. We're going to use this triangle twice because we want to save patty paper. Now we're going to construct the altitude from angle B. How would we construct the altitude from angle B? And actually, to do this one, we actually have to use our ruler. We can't just fold to find an altitude. Okay? So what we're going to do is we're going to take our ruler and we're going to make the bottom of our ruler, flush with side AC. Do you know what it means to be flush? Like it should be lined up perfectly with AC. So you take your ruler and you make sure it's perfectly lined up with AC. Then you're going to drag it over until it goes through angle B. So you're going to slide over, it's flush with the bottom flush. It's hard to do with smartboard. And then boom, when it looks like that, that will be your altitude. You're using the bottom of your ruler as your 90-degree angle. You're using this corner literally as your 90-degree angle. So you're sliding it over until it's going through angle B. And it can't be sideways, like your ruler can't be like that, right? It has to be perfectly level with the bottom. The bottom of your ruler has to be level with AC, level. So once your ruler is perfectly flush with the bottom and your ruler is going through angle B, then make sure you make a segment with your pencil and put the markings that shows it's an altitude. So far you should have this, right? An altitude from angle B and an angle bisector from angle A. Okay, moving on. Now we will construct using our obtuse triangle. So we're done with ABC. I expect for your assessment now you know how to make an angle bisector and you know how to make an altitude. So now you know for tomorrow or for your assessment. Okay, next triangle is obtuse, and we're going to construct the median. Remember, we can't use the markings on our ruler. We're not allowed to use a ruler as a ruler. We're only allowed to use it as a straight edge. So if we need to find the median, how would we do that? The median from angle E to side DF. No, we're not going to make EF touch DE. That was for angle bisector. That's what we would do. We would make the segments touch. There you go. Have point D touch point F. Very good. Fold your patty paper so that D falls directly on F. We're not making the segment fall on the segment. We're making the point fall on the point. That's a little different. So your longest side, fold it so that point D and point F are the same point, and pinch your paper. Don't make a long segment, just pinch your paper. We're not finding a whole segment, we're just finding a midpoint. So pinch your paper, don't make a full segment. So put a dot where the pinch was, and that's your midpoint. So we're starting by finding a midpoint. Once you have a midpoint, then you just connect angle E to that point. You connect them with your straight edge, and you have yourself a median. It's hard to do this on a laptop. Sorry, my median got a little off. When I show you, it's going to look bad. So I'm literally tracing on the laptop. Okay. What marking should we add to our picture? Got a good view of my part there, huh? Tick marks, yes. So that point is a midpoint, so we can add tick marks, add it to your paper. There we go. The median from E to DF. So that's how you find median. You find the midpoint, you pinch it, and then you connect the dots. Last one. Now we're going to construct the perpendicular bisector of EF. Ooh. How are we going to construct the perpendicular bisector of EF? The midpoint, then the altitude. Okay, it's actually easier than you think. You know how I said this last time? I was like, don't make a whole crease, just make a pinch. Well, for the perpendicular bisector, you make the whole crease. That is the perpendicular bisector. So yeah, we're going to put E on F. We're going to put E on F. We saved the easiest segment for last, I think. Put E on F. Oh, it doesn't even say on there. And instead of making a pinch, you make the whole crease. Just make sure dot E is on dot F and make the whole crease. The whole crease. And you have a perpendicular bisector. I'm going to make it darker. Put your ruler on that crease. You can extend it past your triangle. That's fine. Then we would add a box and tick marks. I'm going to add double tick marks because we've already used up single tick marks, right? See if it's going to focus. There we go, focus. So there is a median from angle E and the perpendicular bisector of EF. Good. I'm glad you think it will be easy. So there we go, there we go. And like I said, double tick mark because one tick mark has already been used. Okay? So